Hello everyone, welcome back to my channel. Once again we are starting with the next questions, which is 1.5. Calculate the mass of sodium acetate CH3COONA required to make 500 milliliter of 0.375 molar aqueous solution. Molar mass of sodium acetate have been given, which is 82.0245 grams mole inverse. So over here we have been given the molarity of the solution, which is asked, which is 0.375 molar, okay, which means in 1000 milliliter solution, okay, there is 0.375 moles of sodium acetate is present. Okay, this has been given in the solution. Okay, so let's see that how did we calculate the molarity and number of moles for a particular solution. Number of moles are calculated like this is a solute, and obviously sodium acetate has been made in water. Water is solvent, okay. So solute and solvent, there are two components of the solution. So this particular solution is called binary solution. Okay, binary solution means it has only two components. One is solute, one is solvent. So when we take solute in a binary solution, solute is represented as component B and solvent is represented as component A. So when we have to calculate number of moles, it is given mass divided by molar mass. Okay, so it can be of anything. This is how we calculate number of moles. Now we have been asked that in 500 milliliter how many number of moles will be present. Okay, so what we are going to do, we are going to convert this number of moles, right, which is in 1000 milliliter into 500 milliliter. So you can say that 1000 milliliter of solution contains 0.375 moles of solute. Okay, so 1 milliliter of solution will contain 0.375 divided by 1000, and we have been asked in 500. So in 500 milliliter of solution, 0.375 multiplied by 500 divided by 1000. So two zeros are cancelled. 5 ones are 5, 5 twos are 10, 2 ones are 2, and over here 0.1875. So it comes out to be 0.1875 moles. Okay, to form 500 milliliter of 0.375 molarity solution, we have to take this much number of moles of solute. Okay, so we have to calculate the mass, which is given mass. So molar mass have been given. Molar mass, which is 82.0245 grams mole inverse. Okay, number of moles have been given, which we have calculated over here, 0.1875 moles, NB is equal to W divided by molar mass. What we have to calculate? We have to calculate the given mass, which is equal to Nb multiplied by molar mass. Nb is the number of moles, which is 0.1875 multiplied by molar mass is 82.0245, and we got the mass in grams, which is approximately 15.38 grams. So this is how you will calculate the mass. Okay, now we are going to do the next question, which is calculate the concentration of nitric acid in moles per liter in a sample which has density 1.41 grams milliliter inverse, and the mass percent of nitric acid has been given 69%. Okay, so we have been given mass percent of nitric acid, which is 69%, which means 69 gram nitric acid is present in 100 gram solution. Okay, so we can calculate the number of moles. Before that, we have to calculate the molar mass of nitric acid. So molar mass of nitric acid, HNO3, is hydrogen is 1 gram plus nitrogen is 14 gram plus 3 into oxygen. Oxygen are 16. Okay, so you get approximately 63 gram mole inverse. So molar mass is that. You can calculate the number of moles. The mass has been given. Given mass is 69 gram. So number of moles of nitric acid is 69 divided by 63. 69 is in grams and 63 is in grams mole inverse. Grams and gram cancel and mole inverse goes up and it becomes moles, and which comes out to be approximately 1.095 mole. So this much number of moles are present in 69% of nitric acid. We also have been given density, right, of this particular solution. Density is 1.41 grams milliliter inverse. And we have a formula of density. Density is equal to mass upon volume. Okay, so volume can be calculated. Okay, volume, what we are calculating for, see, 100 gram, right? 100 gram nitric acid solution has been given. So volume of 100 gram nitric acid solution will be equal to, volume is taken that side, mass upon density, mass upon density. Okay, so mass was 100 gram and density is 1.41 gram milliliter inverse, which becomes in milliliter. This comes out to be equal to 70.92 milliliter. Okay, we have been asked that we have to calculate the concentration. So concentration we are going to calculate over here in molarity. Okay, for molarity we need the volume in liters. Either you can convert milliliter into liters or keep it like this. Okay, let's keep it like this. Okay, so what we are going to do, we have to calculate the concentration. Concentration of nitric acid is number of moles of nitric acid divided by volume. That should be in liters, but over here it is kept in milliliters. So what we are going to do, we are going to divide this milliliter with 1000 to convert it into liters. NB into 1000, that 1000 goes from denominator to numerator, volume in milliliters. Okay, so NB was 1.0, let me just check, 95 moles divided by volume in milliliter was, we have calculated 70.92, and we have multiplied this whole thing with 1000 because we have converted it into liters. So the answer over here comes out to be 15.44 moles per liter. Okay, which is once again 15.44 molar. This much solution have, this is the concentration of nitric acid solution, which is given 69%. This is how you calculate the concentration. I hope you have understood that how we have to calculate such questions. Thank you so much. Have a nice day.